Hello friends. Today's question: a person blows into open end of a long pipe. As a result, a high pressure pulse of an air travels down the pipe. When this pulse reaches the other end of the pipe, so we have to find out the which of these four options are correct one, and it is a multi-correct options. Okay. So in this case, we have to take into consideration two principles. First is a wave propagation, and the second one is the boundary condition. So we can say the reflection of pressure wave at the boundary of the pipe at the boundary of pipe. Boundary of pipe means either it will be open or it will be closed. Open or closed. It will be described by first is our wave propagation, and second we can describe it by using boundary condition. So let us frame an equation which represents the pressure of a wave in a pipe. Pressure wave in a pipe, and it can be represented as P of xt will be equal to P naught cos of kx minus omega t, where this P of xt, this is pressure at a position x and time t. Pressure at position x and time t. P naught is the amplitude of the pressure wave. Amplitude of pressure wave. K is the wave number. Which can be also written equal to as 2 pi lambda. 2 pi by lambda, lambda be the wavelength. And omega will be our angular frequency. Which will be equal to 2 pi f, where f is the frequency. And let us understand the reflection at the boundary. Reflection at the boundary. Because as the pressure wave is going to reach the end of the pipe, the nature of reflection will be depending upon whether that end of the pipe is closed or open. So you can say from here that when pressure wave reaches the end of the pipe, it reflects. And this reflection, or we can say nature of reflection, depends on whether the end is closed or open. End is closed or it is open. And based on this, we can you can say and make analysis of the boundary condition. From here we can say boundary conditions. Now if the end is open, if we have open end, then the pressure at both open end must be equal to the atmospheric pressure. You can say from here pressure at the open end must be equal to the atmospheric pressure. And we also call this as a pressure release boundary. This is called as a pressure release boundary. And for this was our open end. Now for closed end, the air cannot move to the closed end, so the velocity of the air is approximately equal to 0. This is called as a rigid boundary condition. The air cannot move at the closed end. So the velocity of the air is 0, and this is called a rigid boundary. Rigid boundary. So let us first of all now discuss the reflection at the open end, and then we are going to discuss reflection at the closed end. Reflection at open end. Now at the open end, the pressure wave reflects with a phase change of pi, that is 180 degree. So at the open end, we can say pressure wave reflects with a phase change of pi, that is 180. So which basically means that a high pressure pulse, which is a compression, reflects as a low pressure pulse, which is our rarefaction. From here we can say a high pressure pulse, which is our compression, reflects as a low pressure pulse, which we also call as a rarefaction. So therefore, mathematically we can write that the reflected wave we can write its equation as P reflected with respect to x and t will be equal to minus P naught cos of kx plus omega t. And this negative sign, this indicate nothing but a phase change of 180 degree. Similarly, we can discuss, or we can say, reflection at closed end. In this case, the pressure wave is reflected, but there is no phase change. Pressure wave reflects without phase change. So which means that high pressure pulse reflects as high pressure pulse. High pressure means compression. So compression is reflected as a compression. And we can write the equation for reflected wave in this case P reflected with respect to distance and time will be equal to P naught cos of kx plus omega t. Now we can just superimpose these two incident and reflected waves. So superposition of incident and reflected waves so therefore the total pressure in the pipe in the pipe let us call that as P total with respect to x comma t will be equal to P incident x comma t plus P reflected x comma t, and we substitute the values. We get this will be equal to P naught cos of kx minus omega t minus P naught cos of kx plus omega t. P naught we can take common, and we have two trigonometric functions, cos of kx omega t and cos of kx plus omega t, which we can solve by using trigonometric identities. So we can get our P total x comma t will be equal to minus 2 P naught, and this will be of a sine of kx multiply by sine of omega t. So means this is a standing wave with a pressure node at the open end. This is a standing wave with a pressure node. Node means basically zero pressure at the open end. And this was our, I forgot to mention, this was for our, you can say, for closed. This was for open end, this particular solution. For open end. Now we can discuss similarly for closed end. And here also we can write that our P total for x comma t will be equal to P naught cos of kx minus omega t, and this will be plus P naught cos of kx plus omega t. Once again, using trigonometric identity, we can solve these two trigonometric functions, and we get this as P total x comma t will be equal to twice P naught cos of kx, and here also we have cos of omega t, and this is our pressure antinode standing wave. So we can say this is a standing wave with a pressure antinode, which basically means maximum pressure. At the closed end. So it means from this entire discussion we can draw two important conclusions. That first one is for open end is a high pressure which is reflected as a low pressure. we can say that high pressure is reflected as low pressure, and in case of closed end, high pressure reflects as high pressure. High pressure reflects as high pressure. So from here we can say there is a phase change, and here we can write no phase change. So from this entire discussion, we can say that option number B and D are the correct options. Option B and option D are the correct options. Option B and D are correct. So it means by considering the boundary condition as well as phase change, we can easily explain the behavior of the pressure wave inside a closed end or open end. So this completes the question. Thank you.